Okay, volume 6. Today is going to be all math, so I'm going to leave all the abstract concepts for later videos and try to get into as much of the basic exposition of the core mathematical ideas as I can in this video. So just real quick, we're going to pick back up on something from the first video, which is this relationship between this sphere, a three-dimensional sphere, and this three-dimensional half cone. The relationship that we were looking at was based on this Archimedean insight regarding a circle being unwrapped into a right triangle of the same area. We observed that you can do that. You can construct this half cone by doing that with regards to the circular subdivisions of the sphere, right? All those circles that are implied by the sphere, you can unwrap into triangles, and you can do that infinitely many times until you generate both of these shapes, essentially. And what we observed is that while the circle and triangle have the same area, these two three-dimensional shapes have different volumes, which means if we deflate the sphere, if we shrink the sphere to 0, it will reach 0 before the half cone reaches 0, even if they're both approaching infinitely a limit of 0. Which means paradoxically that even though this rule is true and it's always true, it doesn't cease to be true arbitrarily. There is a point in that process of shrinking the sphere where the sphere is already gone. It's already collapsed to 0, and yet you still have a half cone, which according to this rule, you ought to be able to collapse or to wrap up into a sphere, but there's no sphere there for you to do that, right? So it's a paradoxical situation, again, where the concepts of 0, 1, and infinity appear to be inextricably equivalent, essentially, right? Even though we want to know that those concepts are not identical, they're not equivalent, they're distinct. Why am I bringing this back up? Because the central paradox of my entire theory for this project of radical depressive realism is going to hinge on this notion of refeeding syndrome paradox, which is taken from medical science, where people who are starving, and they've been starving so severely and for so long, even though the rule of food equals cure for starvation, right? Like you cure starvation by giving a starving person food. That rule is true. However, it breaks down at a certain level of severity where you have to diminish actually the amount of food that you can give to a starving person, or you will kill them. You'll overwhelm their system with the food. And there is a point of severity of starvation where there's literally nothing you can do for somebody. In other words, there's no amount of food that you can give them that won't kill them because they're too far gone. Which is, this is, it's saying the same thing as we are observing geometrically in this situation, namely that, the sphere represents food and the cone represents a starving person, roughly speaking. As the amount of food that you can give them approaches 0, it arrives at 0 before the person has died, right? So you have no more food that you can possibly give them without killing them, and yet they're still alive, which is very paradoxical and very troubling psychologically for us, right? Like we want there to be an answer, and there isn't one. Anyway, moving on. This is going to end up referring to incoherence. What I'm calling the incoherence paradox. That's looking up ahead at the deeper math, but we're just going to try to get to the core math today. So, radical depressive realism, it's a Bayesian theory of suicidal reasoning and thus of suicide prevention. That's going to subdivide into two theoretical notions: a gauge measurement theory for evaluating the severity of depression, just as we would evaluate the severity of starvation. And in fact, depression is going to be interpreted as a form of starvation, and there are many forms. This applies to many aspects of life, this whole refeeding syndrome paradox. That's one of my central claims. So we have a gauge measurement theory, and then we have an intake treatment theory, just like caloric intake theory for starvation, where we have to relate the severity of the depression to the intensity of the treatment, if you will, and also basically take precautions to not overfeed someone, as it were, into and end up unintentionally killing them, even though we're trying to help them, which I think is something that does happen in treatment for depression. That people who are severely depressed end up getting overfed, as it were. In particular, they're overfed optimistic, delusional thinking that isn't referring to the reality of their situation. That makes their depression worse, and it just pushes them closer to suicide. Um, anyway, but the basic equation is going to be P times S over T. P is a pain measurement. It's a measurement of pain neurotransmitters and stress hormones, and even just hormones in general, and vitamin levels and everything. But it's just collapsed into a single value, P. S is the number of cycles through the suicidal reasoning loop. Suicidal reasoning, in my theory, is interpreted as a vicious cycle. It is a degenerative vicious cycle. And we'll get into what that means, but the number of times through that cycle is important in calculating like the probability of you committing suicide, basically. Like the more number of times you've gone through this, the more, starved you are, in a sense. And then time is defined according to the philosopher McTaggart's definition of the C series. I agree with McTaggart when it comes to the contradictoriness of the so-called A and B series in conceiving of time. So we'll get to all that, but I just want to give a clear, opening exposition. So the math, this concept, the chirality of the negative / positocentrism. This is a neologism of mine, I guess. It's similar to Derrida's notion of logocentrism. I have a lot of criticisms of Derrida, but he has some important points, and that's one of them. What he means by logocentrism is the intuitive presupposition throughout human history of the priority of speech over writing, effectively. And that we assume this for intuitive reasons, but it's not necessarily true. It's not logically necessarily the case that speech is superior to writing or more fundamental than writing. That's Derrida's claim. I'm making the same claim with regards to positivity and negativity themselves as concepts, that we tend to privilege positivity even in the abstract mathematical sense. So not just in the sense of like the positive thinking therapy that you get as a severe depressed person trying to get help, which ends up not being very helpful at all, but even in mathematical terms. So positocentrism is an example of optimism bias, and as we already went over, optimism bias is cognitive bias, right? Like these are synonymous concepts ultimately. Okay, so what is the most fundamental concept in mathematics? The answer is chirality. This is the most fundamental concept. What does chirality mean? What is this referring to? Well, it's basically positive versus negative, or left-handed versus right-handed, or 0 versus 1, or being versus nothingness, right? It's this binary fundamental duality that has to do with abstract qualities. So it's not yet referring to numbers. It's not yet referring to any mathematical object. In fact, these aren't mathematical objects per se. These are operators, or they are, designators. They denote an orientation, right? And one isn't any more fundamental than the other. You can't have one without the other. You need both, right? Just as we need both the infinite and the finite conceptually, we can't do without one or the other. It's both. Okay, so in my theory, chirality is the most fundamental mathematical concept, then topology, then number, and then everything else. So geometry, algebra, set theory, information theory, complexity theory, category theory, all that whole thing, computation theory. So I'm convinced of this for philosophical reasons. However, I do have an empirical basis for thinking this. Namely, Jean Piaget, he was a child psychologist. He wrote a book called Genetic Epistemology. In there, he says essentially this, that the most fundamental concept of psychology is what he calls overtaking, which is essentially just the overtaking of the positive with the negative, or the overtaking of the negative with the positive. Basically, any change, any qualitative change that denotes this kind of fundamental binary distinction. That's the most fundamental notion. And then he observed that for children, when they administered mathematical tests for very young children to see how they conceived of different mathematical ideas, topology was the most fundamental thing. It was the most intuitive notion for young children, and thus for all of us as human beings. And everything having to do with number, magnitude, length, geometry, angle, identity, numerical identity, etc., variables, and even the idea of a set even the idea of like of a collection of anything was more abstract than just pure topology. Also, in molecular evolutionary biology, a similar thing is observed with regards to cells, with regards to the most fundamental life forms, that they are engaged in binary qualitative distinctions and choices that have to do with these kind of conceptual chirality here. So anyway, moving on. What is a negative number? So there's this guy Maceres. He was a mathematician, I think, in the 18th century. He was also a judge. So fuck Maceres. I think I've already explained my position on judges, that they are the most despicable people on earth, basically. But so he tried to claim that negative numbers don't exist, that they're an illusion, and that we should do away with them, basically. So he was wrong, and there are many reasons why, but he did have a point, and a very important point. And his point was essentially the chirality of square roots in particular. Meaning what? Well, a square root is both positive and negative, right? It's not one or the other, it's both. Which means that you can conceive of a square as being, say, like having side lengths of 5 units. So 5 times 5 gives you an area of 25 square units for this given square. So the square root of 25 is 5, of course, positive 5. However, it's also negative 5, according to all of our mathematical assumptions. So what are we describing there, right? If a square has side lengths of negative 5, it also yields an area of positive 25. What, is it visible? Is it invisible? Like, what, does it exist in this universe? Like, what are we talking about? Where are these side lengths? Right? That was Maceres' point, is like something is deeply counterintuitive, and he was right about that. He wasn't right that we can do away with negative numbers, because he was a judge and he's very used to just doing away with things that he doesn't like and sending them to prison and punishing people from on high with impunity, because he's a fucking judge, so fuck him. Anyway, there are some empirical proofs for negative numbers, though these are ones that we usually would refer to today to challenge Maceres. So economics, the concept of debt. I'm an anarcho-pessimist. I don't believe in the necessity of the concept of debt, but there's an apparent inescapability, it's not the same thing as necessity, of debt in all complex or modern markets. So everywhere you look where there's any commerce going on, the concept of debt is part of the mathematics that is going on there. More importantly, I think, complex and hypercomplex numbers in physics. So complex numbers are based on this notion of I, of so-called imaginary numbers. They're wrongly named that, but they involve the square root of a negative number, right? So you can't have this concept without negative numbers. And complex and hypercomplex numbers appear very fundamental, like in very fundamental, indispensable ways in the standard model of particle physics and string theory and quantum computing. In other words, they're right there at the center of all of modern physics. So our best attempts to describe nature involve negative numbers, right? Like you can't do without them. And then a specific example is negative 1/12, which has this very interesting significance in physics and string theory in particular. There's a video that just came out from a string theorist on Numberphile explaining recent developments with this. That's really interesting. I can't go into it right now, but anyway, so those are the three main ones. But yeah, we have this issue of positocentrism. Positive square roots are considered principal or more primary, but they're not, right? We just intuitively assume that. Why do we have this cognitive bias, this optimism bias with regards to the positive? It's because we can't intuitively define what it would mean to learn to count with negative numbers first, right? And I invite anyone watching this to just stop and try to think of, like, what would that be if you tried to teach a child, for example, to count by counting negative numbers first? How would you, right? You're referring to things that don't exist, and then things that continue to not exist. Even, how would you establish the notion of magnitude or a successor case? I don't know. I mean, I don't think any of us know. I don't think the human brain really has an answer. And that's why we intuitively assume the primacy of the positive, but that's a bias issue, a cognitive bias issue. So anyway, what is a negative number? And more importantly, why do we assume that we know what a positive number is in the first place, according to positocentrism? In other words, we're just assuming that the positive is intuitive because we can give examples, but can we define that mathematically? Well, we begin with this additive identity axiom, right? So we're claiming that there's some operation that they can use to relate a number to itself such that it equals 0. And then we just axiomatically define that thing to be the negative, right? So we have this concept of negation and opposition. 2 minus 2 equals 0. Very intuitive, very like, no one challenges this sort of thing. But this is tautological. In other words, we're not really defining it with any more fundamental concepts. From here, we jump to the double negative rule, and we try to give a proof of that. Like, how can you give a proof of the double negative? Well, you can only do it by relating it to the additive identity, right? So negative 2 times 2 is negative 4. Therefore, the double negative of negative 2 times negative 2 must equal positive 4 to maintain the additive identity, right? So we still haven't like resolved this, but these are our axiomatic assumptions. So let's look at the double negative thing a little closer. 5 times 5 means what? It's 5 plus 5 times, of course. That equals 25, no problem. Negative 5 times 5. Well, it's negative 5 plus negative 5 times. That equals negative 25. Okay, good. So we have an opposition here. But here's our double negative. Negative 5 times negative 5 equals negative 5 plus negative 5 times. Right, but what does that mean, really? So the only way we can make sense of this is to take what we just did above and then add another negative sign, right? Which means we have 6 negatives. And this is kind of Maceris's point, is like, that's a little strange, right? Yeah, this yields positive 25, and we can continue to do math with this, of course. Like, math isn't broken in any clear sense, but it's counterintuitive, right? So we still have this chirality of square roots issue, where you have two things that should be opposite yielding the same thing. And if these were just numbers, that wouldn't be a problem. Like 4 plus 1 equals 5, 2 plus 3 equals 5. It doesn't matter that those are different numbers yielding the same thing. However, with this abstract concept of negative and positive themselves, you would assume that there'd be some trace of opposition in the result, and there isn't. So what's going on there, basically? So so we accept the negative numbers, and then from there we end up building up to complex numbers with the square root of negative 1. How do we explain I times I with addition? Well, it's I plus I times. Sure. Okay, what does that mean? We don't know, right? We can't explain it, right? You'd have to write it like this, but this seems rather trivial, right? You have like a positive square root of negative I, a negative square root of negative I, so those cancel, and then you just have negative 1, and then equals negative 1. And you do the same thing for these, but these are clearly just mapped from our assumptions with the integers. So we can't give any deeper definition. And in fact, chirality continues to haunt the negative all the way up the hypercomplex staircase. And eventually we'll go up 5 steps, the 2 to the 5 dimension hypercomplex number system, a 32 dimension number system. The trigentaduions or pathions for pathological. We'll get there, but it's remarkable that you can only take 5 steps up this infinite staircase. It's an infinite staircase before everything we know about mathematics pretty much breaks down. So chirality continues to haunt that process. I'm going to go 2 steps up at least, and we'll look at quaternions a little bit. Complex numbers are the first step. The real numbers are the floor. The first step is complex numbers. The second step is quaternions on the staircase. When we reach the second step, we deal with this issue of anti-commutativity. Well, what is that? Well, it's, again, the chirality of the negative and anti-positocentrism issue, which, just real quick, the IJK is Hamilton, the mathematician Hamilton, who came up with quaternions officially, even though Carl Gauss also discovered them because that motherfucker discovered everything. IJK equals negative 1. If these were commutative, then any arrangement of these with commutative multiplication would equal the same value. But these anti-commute, meaning in reverse order, they equal the opposite value, right? So you can depict this rotationally. It's negative 1, positive 1. A lot we could say about that, but let's just look at the pure expression of the double negative axiom. So 2 negatives equal a positive. That's the same as a negative equals, negative positive. Negative divided by negative equals positive. These are all the same thing. So let's just look at an infinite series of positive signs and an infinite series of negative signs. How could we simplify this according to our rule? Well, positives don't simplify, right? Any number of them together just yields another positive sign. So this is an example of positocentrism. In other words, we assume positives are more principal precisely because they don't simplify, precisely because we defined them that way. right? But what about negatives? Well, negatives we can simplify, right? We have a rule for that. So we can couple every two negative signs and reduce them into a positive sign, and we can do that infinitely, and that will give us an infinite sequence of positive signs. However, we don't know the ultimate even or odd number of negative signs in the sequence because it's infinite. Therefore, it also implies a sequence of negative signs, an infinite sequence of negative signs, which we could then attempt to simplify in this way, and that continues recursively, this process. So our attempt to simplify is just going in a circle, right? We're not simplifying it. We're actually just extending it infinitely, which leaves us with just, ultimately positive infinity and negative infinity. And we know that positive infinity minus infinity is Riemann's paradox, which is indeterminate, meaning it means anything, and we don't like that intuitively. So this is why we don't like this indeterminate feature of attempting to simplify the negative infinitely. We much prefer that the positives don't simplify, so we can just have a stable definition of positive, the concept of positive infinity. Positive infinity plus positive infinity equals positive infinity. Look at it that way, right? So that makes intuitive sense, whereas positive infinity minus infinity equals indeterminate. It's whatever you want. So the chirality of the negative equals Riemann's paradox equals chirality of the square roots issue, the positive centrism, anti-positive centrism issue equals indeterminate. So like all of this is leading us to a conclusion of indeterminacy, irresolvable indeterminacy. So let's look at axiomatic constructions that we would look at in piano arithmetic. So generally you would start this way. So you start with a zero case, then you have a successor case. Again, positive centrism here, we're assuming that the successor case should be positive. So you have 0 plus 1, and then just plus 1, plus 1, plus 1, and from there you have the whole number sequence up to the infinite. So you have an infinite limit case, and then we have negation, opposition, the predecessor case of the negative. But again, we could do the opposite, even though it's not intuitive to us as humans at all to learn to count with negative numbers. But we could mathematically construct them that way with a zero case and then a negative successor case, negative centrism, if you will, and that could be extended to a limit case of negative infinity, and then we can establish a positive predecessor case with negation and opposition. So let's look at what that means, right? And we want to take a moment to examine this. So we start with 0, and then we have a positive successor case, and let's say we do that twice and we get to the number 2. And then from here, rather than going off to the infinite and then just arbitrarily assuming the negative axiomatically, how can we get from positive 2 to the concept of negative 2 without having established what negative means? In other words, we can't walk backwards through the predecessor case in order to walk into the negative number line. We haven't constructed that yet, basically. So we can only invoke a positive concept to reach this. How do we do that? Well, if we go in the positive direction infinitely, the only way to circle back around and come out this other way is if this is on some kind of circular surface, some kind of ring surface such that the topology is curved, and like the globe, if you're going around the equator, you'll eventually arrive back at the same point. However, that would suggest that positive infinity is somewhere equivalent to negative infinity, right? And that these things overlap as concepts. So that's problematic, right? So what else could we do? Well, two-dimensionally, we could rotate in the positive direction, in the sense of a positive angle, even though we don't need a specific angle necessarily. But rotationally, we're saying somewhere out there is the negative, right? We don't have this linear function yet, but somewhere out there we can rotate into the negative. That might seem strange, but let's look at it a little closer, and we'll imagine that we're doing a beach sand construction with Archimedes, let's say. That'd be pretty interesting in itself. But you want to do a precise construction of this idea with primitive tools. So you have a primitive compass, it's just 3 sticks, let's say, and one stick is tied to the other 2 to lock them in place. So you have a given angle, a given radius, length as well. So with that, you can construct in the sand a good, reliable circle. And then you can just drape anything like a piece of string or seaweed or whatever across the circle circumference. And wherever that arbitrary line intersects the circumference, you can, with your compass, establish those points. And you can call one positive and one negative, and say that they are related rotationally across the axis implied by the center point of the circle. So you can go from here, and you can from the positive, and you can go to the negative, and you can go to the positive and the negative, and you can like intuitively do that thing, right? So you have some kind of intuitive definition of what the relationship between the positive and negative is. So let's look at that a little closer and imagine that we have two number lines, a positive and a negative, and they're tangential to a circle. And let's say that this circle can just continue to expand at whatever level of number line of at whatever number you're wanting it to be tangent to the line at, right? So let's just say it's at number 2. So this is saying that we can rotate, we can go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, infinitely and arrive at -2. And vice versa, we can go 0, -1, -2, -3, -4, -5, -6, -7, infinitely into the +2. So the rotational relationship is intuitive, but this implies a strange, paradoxical, apparently contradictory idea, which is that the sum of the positive integers is equivalent to the sum of the negative integers, which is the same as saying positive a equals negative a, and that's just a straightforward contradiction, right? So this is the deepest, most paradoxical expression thus far of the chirality of the negative issue, right? So what we're trying to do is we want the positive or the negative to be related to each other rotationally. So if we write this equation where it's where we're invoking a summation, a geometric series in this case, we want there to be some kind of summation, some kind of summed series relationship between these two that's also rotational. What would that be? Right, and this is just a look. We're going to get deep into that, but this is just a look ahead at how a chirality issue, a sign inversion issue, a sign flip. You look at these two series, and we have a sign flip on the inside and the outside of the parentheses. How that can be represented with just a positive factor here. So like this 1/3 yields ultimately -1/3. So we're in a sense like rotating. You might want to envision that we're rotating between the positive and the negative here. This is just another example of that. Which leads us to the next concept related to the chirality of the negative, Mobius strips, which are also square roots. So the chirality of square roots is at play. This is, of course, related to the whole positocentrism, anti-positocentrism issue, which is related to the Riemann paradox and indeterminacy. So the cylinder definition of positive and negative, which I'm going to define with or notation, what I'm calling or notation, meaning positive or negative, as opposed to and notation, meaning positive and negative. So this is a tautological definition. We've already dealt with that. The cylinder has two sides, an inner and outer. We can designate either as positive or negative. So here the outer is positive, the inner is negative. It's two sides, and there's a clear distinction between the concepts of convergence and divergence expressed here. So like -1 we can express as a convergent negative geometric series. +1 we can express as the sum of a positive geometric series. So this is all true, this is all consistent, but it's not really addressing the deeper indeterminacy issue, is it? So then we have a Mobius strip definition of positive and negative with and notation. So this is a one-sided object in the sense that these are two Mobius strips intersecting, and you can trace, if you're a one-dimensional ant, you can trace the surface and at any point make a chiral decision as to which Mobius strip you want to cycle around. You can cycle around both of them infinitely. You can cycle around each one of them infinitely. So there is a sense in which they appear to be two surfaces still. However, they are unified at the same time, which means, okay, now we're getting into like a paradoxical expression where convergence and divergence are not neatly delineated, and we can represent this with what I'm calling and notation, which as far as I know is something I've invented, quote unquote. It's just a logical extension of obvious things. But I'm doing this just to express that you can interpret this infinite sequence as being either positive or negative, depending on whether it's even or odd. And because it's infinite, it's neither even or odd. So you have at the same time positive or negative one. It's neither one or the other, it's both, which is the same issue as infinity minus infinity, which is our Riemann paradox, which is the indeterminate. So here's some physical Mobius strip expressions of this, right? So that's just a three-dimensional expression of the same idea. These are both true, right? But this we can just get rid of because it doesn't address this deeper philosophical problem. This does. So we're going to continue to use Mobius strips all the time. Here's some wacky Mobius, this is like, involving arbitrary curves. Here's a Mobius strip tangentially containing another one. Here's an abstract expression of that number line tangency relationship where there's a Mobius strip instead of a circle, and the number line is a floppy, thing that's tangent to the Mobius strip, which you can also tie into another Mobius strip, of course. Here's a Mobius strip with 3 twists instead of 1, just because that's rare to see. Here's one that's just a complete mess. It's like that Nirvana song, Very Ape. This is very physics. It's very physics. Yeah, it's very physics. And here's a specific Mobius strip